തിയറം 2.19 ആണെന്ന് ഡിസ്കസ് ചെയ്യുന്നത്. സ്റ്റേറ്റ്മെൻറ്റ് പറയാം. കൺസിഡർ ദ കോഷി പ്രോബ്ലം എഫ് ഓഫ് എക്സ് വൈ പി ക്യൂ x y u p q equal to 0 and x is equal to x naught of s and y is equal to y naught of s and u is equal to u naught of s. Assume that the generalized transversality condition f of p naught is equal to 0 and u naught dash of s naught equal to p naught of s naught into x naught dash of s naught plus q of s naught into y naught dash of s naught and x naught dash of s naught into f q p naught minus y naught dash of s naught into fp p naught not equal to 0 holds at p naught. Then there exists epsilon greater than 0 and a unique solution x of t of s, y of t of s, u of t of s, p of t of s, q of t of s for the Cauchy problem, which is defined for mod s minus s naught plus mod g less than epsilon. Moreover, the parametric representation define a smooth integral surface u is equal to u of xy. ഈ ഒരു കോഷി പ്രോബ്ലത്തിന് ഈ കോഷി പ്രോബ്ലം ഹാസ് എ യൂണിക് സൊല്യൂഷൻ ഓൺലി ഇഫ് ദി ട്രാൻസ്വേഴ്സാലിറ്റി കണ്ടീഷൻ ഹോൾഡ്സ് അറ്റ് പി നോട്ട്. ഓക്കെ, ആൻഡ് വി ക്യാൻ എലിമിനേറ്റ് ടി ആൻഡ് എസ് ടു ഒബ്റ്റെയിൻ ഇൻ്റഗ്രൽ സർഫസ് ഇൻ ദി ഫോം ഓഫ് ആൻ എക്സ്പ്ലിസിറ്റ് ഫംഗ്ഷൻ യു is equal to u of xy. അതിൻ്റെ പ്രൂഫ് നോക്കാം. Given the Cauchy problem, f of xy pq is equal to 0 and initial condition നമ്മളത് x is equal to x naught of s and y is equal to y naught of s and u is equal to u naught of s. Named as equation 1 and 2. The characteristic equation to our Cauchy problem is xt is equal to fp and yt is equal to fq, ut is equal to pfp plus qfq, pt is equal to minus fx minus pfu, qt is equal to minus fy minus qfu. This equation named as star. The initial condition for x, y, u is already provided by the Cauchy problem. That is x is equal to x naught, x of 0 is equal to x naught of s and y of 0 is equal to y naught of s and u of 0 is equal to u naught of s. Next we have to find the initial condition for p of ts and q of ts. That is, we have to find p of 0s is equal to p naught of s and q of 0s is equal to q naught of s. Clearly, at each point of s, p naught of s and q naught of s must satisfy the differential condition and u naught dash of s is equal to p naught of s into x naught dash of s plus q naught of s into y naught dash of s, named as equation 4. That is, we know that u naught of s is equal to u naught of x naught of s and y naught of s. From this we can write u naught dash of s, ux naught of s into x naught dash of s plus uy naught of s into y naught dash of s. And നമുക്കറിയാം യു എക്സ് നോട്ട് ഓഫ് എസ് എന്ന് പറയുന്നത് പി നോട്ട് ഓഫ് എസ് ആണ് ആൻഡ് യു വൈ നോട്ട് ഓഫ് എസ് ഇസ് ഈക്വൽ ടു നമ്മളെടുത്തത് ക്യു നോട്ട് ഓഫ് എസ് ആണ്. And f of x naught of s, y naught of s, u naught of s, p naught of s, q naught of s is equal to 0. This 4 and 5 system holds only at s naught, s is equal to, at the point s is equal to s naught, at the condition, at this condition, this system holds. അടുത്ത് നമുക്ക് ഫൈൻഡ് ചെയ്യാനുള്ളത് ജാക്കോബിയൻ ഓഫ് ദിസ് സിസ്റ്റം ആണ്. അതായത് നമുക്കറിയാം എക്സ് ഇസ് ഈക്വൽ ടു എക്സ് നോട്ട് എഫ് ഓഫ് എക്സ് വൈ ആൻഡ് വൈ നോട്ട് ഇസ് ഈക്വൽ ടു ജി ഓഫ് എക്സ് വൈ. ദെൻ ദ ജാക്കോബിയൻ വി ക്യാൻ ഡിറ്റർമിനൻ്റ് ഓഫ് ഡോ എഫ് ബൈ ഡോ എക്സ്, ഡോ എഫ് ബൈ ഡോ വൈ, ഡോ ജി ബൈ ഡോ എക്സ് ആൻഡ് ഡോ ജി ബൈ ഡോ വൈ. നമ്മളിവിടെ കാണാനുള്ളത് ദ സിസ്റ്റം 4 and 5ൻ്റെ ജാക്കോബിയൻ ആണ്. വിത്ത് റെസ്പെക്ട് ടു പി നോട്ട് ആൻഡ് ക്യു നോട്ട് അറ്റ് എസ് നോട്ട് ആണ്. Jacobian at s naught is equal to dou u naught dash by dou p naught into dou u naught dash by dou q naught, dou f by dou p naught, dou f by dou q naught at s naught, which is equal to determinant of x naught dash of s, y naught dash of s, fp of p naught, fq of q naught, then which is equal to x naught dash of s naught, fq into fq of p naught minus y naught dash of s naught into fp of p naught. By the transversality condition, we can say that j is not equal to 0. Therefore, by the implicit function theorem, we can define the required initial condition for p and q, that is p naught and q naught, from the system 4 and 5. Hence, the characteristic equation have full set of initial condition in a neighborhood of mod s minus s naught less than delta. The system is well posed, which means there exists solution, and second one is the solution is unique, and third one is stability. These three condition holds then the system is said to be well posed. Since the system of ODE is well posed, then the existence of unique solution, that is the solution x of t of s, y of t of s, u of t of s, p of t of s, q of t of s is guaranteed for Ts in a neighborhood of 0 s naught. That is, the solution has satisfied our PDE f is equal to 0 in a neighborhood of 0 s naught. That is our solution f of x of t of s, y of t of s, u of t of s, q of t of s, p of t of s is equal to 0 for all mod s minus s naught less than delta mod t less than q. Next part of this theorem is we have to show that the parametric representation define a smooth integral surface u is equal to u of xy. Now our solution in term of t and s. The parametric representation x by u will define a smooth surface u is equal to u of xy. For that, we must show that the mapping x of t of s, y of t of s can be inverted into a smooth mapping t of x by s of xy. That is the parametric, that is xyu in parametric form. That is xyu in terms of t and xyu function in terms of t and s. U is also in the terms of t and s. Now we have to convert this parametric form into a function of xy, into a function of x and y. We have to convert this mapping x of t of s, y of t of s into a smooth mapping t of xy, s of xy. Such an inversion exists only the Jacobian doesn't vanish. That is, j is not equal to 0. We know that j is equal to dou of xy by dou of t is not equal to 0. നമ്മൾ പോയിന്റ് 0, s naught ആണ്. So Jacobian at 0, s naught is equal to dou of xy by dou of ts at 0 s naught, which is equal to determinant of xt xs yt ys at 0 s naught. Xt at 0 s naught into ys at 0 s naught minus xs at 0 s naught yt of 0 s naught, which is equal to fp 0 s naught, ys 0 s naught, xs 0 s naught into fq 0 s naught. From characteristic equation നമുക്ക് ഇങ്ങനെ എഴുതാം. At t equal to 0, y is only the function of s. then we can write y naught dash of s naught into fp of p naught minus x naught dash of s naught into fq of p naught, which is not equal to 0 by generalized transversality condition. Now we get the Jacobian doesn't vanish, that is the inversion exists. Therefore we can only convert it into solution in parametric form into a smooth function. Thus we have construct a smooth function u of xy. Now we have to show that u of xy satisfy the Cauchy problem of our nonlinear PDE. For that we have to prove that the relation ut and us at a ts. ut of ts is equal to ux of ts into xt of ts plus uy of ts into yt of ts, and us of ts is equal to ux of ts into xs of ts plus uy of ts into ys of ts. Now we have constructed u in the terms of x and y. Now we have to show this u of xy satisfy the Cauchy problem for our PDE. For that we have to prove that ut and us relation hold. ut of t of s is equal to p of t of s into xt of ts plus q of ts into yt of ts. This is equation number 6. And us of ts is equal to p of ts into xs ts plus q of ts into ys of ts. Now we have to prove this relation hold. Equation 6, our ut of ts is clearly valid by the characteristic equation. So ut is equal to pfp plus qfq, which is equal to pxt plus qyt. Also us of ts is valid when at t equal to 0. At t equal to 0, us of 0s is equal to p of 0s into xs of 0s plus q of 0s into ys of 0s. Then u naught then നമുക്ക് എങ്ങനെ എഴുതാം? u naught dash of s naught is equal to p naught of s naught into x naught dash of s naught plus q naught of s naught into y naught dash of s naught, which is valid since it is the given compatibility condition or star. Now it remains to show that our ut now it remains to prove that now 7 is also valid for the values of t other than 0. For that define an auxiliary function. For that define any auxiliary equation r of ts is equal to us minus px minus qys to show that r of ts is equal to 0. We already proved that it is true for t equal to 0. That is r of 0 is equal to 0. To check r equal to 0 for other values of t, we compute rt is equal to ust minus pxt minus xspt minus qyst minus ysqt, which is equal to ust minus pxt minus xspt minus qyst minus ysqt minus psxt minus qsyt, add psxt and qsyt to compensate our equation. That is the last term. that is USST minus QSY dou by dou S of PXT minus dou by dou S of QYT plus PSXT plus QSYT minus XSPT minus YSQT. ഡോ ബൈ ഡോ എസിനെ ഒരുമിച്ച് എഴുതാം. ഡോ ബൈ ഡോ എസ് ഓഫ് യു ടി മൈനസ് പി എക്സ് ടി മൈനസ് ക്യു വൈ ടി പ്ലസ് അതർ ടേംസ് പി എസ് എക്സ് ടി പ്ലസ് ക്യു എസ് വൈ ടി മൈനസ് എക്സ് എസ് പി ടി മൈനസ് വൈ എസ് ക്യു ടി. By 6 we know that our 6 is ut minus pxt minus qyt is equal to 0. Then psxt plus qsyt minus xspt minus ysqt is remain, which is equal to psfp plus qsfq minus xs minus fx minus pfu minus ys into minus fy minus pfu. pt and qt rewrite from characteristic equation. That is rt is equal to fu into pxs plus qys plus ps into fp plus qs into fq plus xs fx plus ys fy. Now adding and subtracting us fu these terms, then our rt become fu pxs plus qys plus psfp plus qsfq plus xsfx plus fsy fy plus usfu minus usfu. Now differentiate f equal to 0 with respect to s. We get fx as xs plus fy ys plus fu us plus fp ps plus fq qs is equal to 0. Then our rt fu pxs plus qys minus fu us. ഇതിന് fu ഔട്ട്സൈഡ് എടുത്താൽ fu pxs fu into pxs plus qys minus us, which is equal to fu into minus r. rt is equal to minus fu r. Then rt എന്ന് പറഞ്ഞാൽ dr by dt ആണ്. dr by dt is equal to minus fu into r. With the homogeneous initial condition r of 0 is equal to 0. dr by dt is equal to minus fu dt. Integrating we get ln r is equal to minus fu t plus constant c1. Then r is equal to e raised to minus fu t plus c1. Then r is equal to c e raised to minus fu t, or c is equal to e raised to minus c1. r of 0 is equal to 0. Then c e naught is equal to 0. Then c is equal to 0. Therefore our r becomes 0. That is r of ts is equal to 0 for all t. So our 7 system is also valid for all t. Hence our proof.